Hi, today we'll be deriving the Newton's second law in polar coordinates. So we have our axis x and y, and we have a vector r. So this is my distancing x, and this is my distancing y. X to be r cos of this angle phi, and y equals to r of sine phi. And this will give us that r equals to x squared plus y squared, and that phi equals to the arctan of y over x. So this is my unit vector. So unit vector, it has the same direction as r, but it only has magnitude 1. So it is equal to my r over r. And this r with 2 bars means the magnitude of my vector r. Basically the length of my vector. Okay, so as we can see here, we can describe this system using x and y coordinate, but we also could describe this system using r and phi. So we would have my r hat and my phi hat here. Okay, so we can describe our force in terms of my fr and f phi hat. Now notice that with this definition we can write r equals to r hat. Just to distinguish them, my vector r will always have this flash on top of it, my unit vector will always have this hat, and my length would just be this, would just be a r. So consider a small displacement in r. So say this with my r in time 1, r in time t2, and I'll have my unit vector pointing in these directions. So this will be my unit vector, and this angle will be my change in phi. Okay, so I have my r1 and my I'll have my t1 and my t1 plus delta t, which equals to my t2. So for small delta t, we can approximate delta r hat to be approximately delta phi hat. Okay, and delta phi is essentially the angle, and we can write this angle as phi dot delta t phi hat, which approximately equals to this. So you can think this as the position, this as a velocity, and this is a time. So position equals to velocity times the time. And so we can divide delta t in both sides to get delta r hat over delta t, which will equal to phi dot phi hat. And if we take the limit as delta t goes to 0, we would get dr hat dt equals to phi dot phi hat. So this will be useful later on. Okay, so we defined my r in this way, so we can take the derivative of this. Since I have two components, I have to do a product rule. So my r hat dot would be equal to r dot r hat plus r hat dot. Okay, well, where my r hat dot is just the derivative, so the dot is essentially taking the time derivative of my variable. Now velocity is defined to be my r vector r dot, which equals to my r dot r hat plus r, and then this thing. phi dot phi hat, which we derived earlier. So in velocity, in polar coordinates, the velocity can be decomposed into two components. First, Vr, which has only r dot, and V phi, which has r phi equals to r omega. Okay, now we can take the derivative of v, i.e. the second derivative of r. So my acceleration would be equal to the second derivative of my vector r, which equals to d dt of r dot vector, which is this term, derivative of this term. Okay, so now we have to do another dot product, a product rule, but before that we have to figure out, because this thing equals to phi dot phi hat, we're going to take a derivative of phi hat, so we have to figure out what phi hat is. So we're going to look at the graph again. We have x and y here. We have my first position, second position, and this is my delta phi. Now, my phi hat at different position are just perpendicular to this. So this is my phi at t2, phi at t1, phi hat. And we're gonna have, if we just draw the vectors like this, I have a terrible drawing. Phi hat t1, and this difference will be my delta phi. Okay, and we can see that my delta phi is actually in the opposite direction of my r hat. So similar to here, we can say d phi hat over dt equals to minus, okay, let's just put it phi dot, because that's the change of phi with respect to time, and then r hat minus r hat, which equals to minus phi dot r hat. Okay, so now we know what this is. We can go back to here. So we have to take a product rule of this, and we have to apply product rule twice here. So what we get is r double dot r hat plus r dot r hat dot plus r dot phi hat. We're taking the derivative of this, which equals to r double dot r hat plus r dot, and this is this. So phi dot phi hat plus r dot. We're multiplying by just simply phi dot phi hat, and then adding r derivative inside, which is phi double dot phi hat plus phi dot phi hat dot, which we got from here. So we would get again this term, and this term has a r hat. Okay, I'll just write it out. Plus r dot phi hat plus r dot phi dot phi hat plus r phi double dot phi hat plus phi dot, there's r, and then minus phi dot r hat. Okay, so we'll group the r's together. We'll get r double dot minus r phi dot squared with r hat, adding what we get here, this is 2, so we'll get a 2r phi double dot plus 2r dot phi hat. Okay, so this is our acceleration in polar coordinates.